Okay, I'm going to try making this a little bit bigger by zooming in, but unfortunately, because of the way my camera's set up, the camera's at an angle right now, so it might be harder to read. I'll be using, Professor suggested using felt tip pens for the next set, and I'll be buying some of those over the weekend. Anyway, I'm making this video because problem 4 has the second most number of views, and that is concerning me because I didn't think that the problem 4 was particularly complicated, so I didn't put that much as much detail into that one as I did with number 1 and 3. So here is your detail. You have, I'm not gonna show you the original problem right now, but you have a truss basically. I think what a lot of you might be having trouble with is figuring out how to you have I'm at the edge of the camera. You have a force P here, and you want to know, or I think you're having trouble with figuring out how to calculate the axial load in these two members. Remember that only members in compression can fail by buckling, so your P critical formula is designed to calculate that the buckling force that will cause a failure. But you need to keep in mind two things. These two members, let's call this 1 and call this 2. 1 and 2 have different diameters, and they also have different lengths. And because of that, you're going to get two different P criticals. P critical 1 and P critical 2. Now, it's not enough to just compare these two, because this load is applied to these two members in different proportions. Because I think it's trivial. If you draw this, I'll give you one angle. You can figure out the other angle. This is L over 2. This is L over 2. So these two must be 45 degrees, right? This is L. You can use trig to figure out this angle. You can use arctan. When you figure out this angle, you want to use sum of forces. So let's look at this point. Let's call this point C. Let's call this A, B. You normally label your reactions first, and then label all the free points in the order of interest, or from left to right, or some scheme, but it's not important right now. You have at this point C. So at this point C, you have a load P, you have F1, you have F2. Now recall, this is a truss problem, so you don't need to worry about like, oh, does this member have forces like this and like this? No, it just has this component, and you can break this up into components that you want. But we're only interested in the axial component. You're not interested in the x component and the y component. You're interested in the component that is in line with the member. So if we draw this, and the solution, the professor calls this alpha and calls this beta, and I will use that same notation. I think the beta that he calculates is incorrect in his problem, but it does not affect your final solution. It does not affect his final solution. You need to have the correct beta, but the way he solved it, he doesn't. The actual value of beta for him doesn't matter, because he just uses the sine beta is equal to opposite over hypotenuse, right? So he doesn't actually need the angle of beta. If we sum forces in the x direction, we get F1 sine alpha equals R2 sine beta. And I hope this is okay. We're interested in finding this. Sorry, this should be F2. We're interested in finding these two forces. To find these two forces, we need to look at the components. Because these are what our equations are defined in, but we don't want to use these later. We just want to find, you're just using the angles, basically, to find the components. And then you have two unknowns, right? So you need two equations. And I'm not going to give you Fy, but I'll say that this P is going to be on the left side of the equation. On the right-hand side are going to be your two forces. I'll just give this to you. It's actually pretty trivial. I keep using R. This is F. So let me write this again. Solving these two equations will give you F1, F2. You already have an equation for PCR. You'll be given PCR. You won't be given PCR. You'll have a formula for PCR, which you'll just leave in terms of unknowns, and you'll have an equation for the force. So what does this mean? If PCR1 is less than PCR2, and F1 less than F2, sorry, F1 greater than F2, then you know that F1 has to control. Likewise, if it's greater than and less than, you know that F2 has to control. It's when these two things are the same or like this that you need to check both. And I can't really, I can't think of a way to articulate this very clearly, but the calculating the capacity is not enough because the forces are loaded at different proportions. And I think that might be why so many people are having trouble with this problem. I don't know. Nobody has emailed me. I don't know if people have been emailing Naveed, but nobody's emailed me questions about this problem in particular. Maybe it's just because it's the last one and you guys haven't gotten to it. But if you have any specific questions about this, I'm a little concerned because there's so many views on this particular problem. But definitely let us know if you have any questions. I'll be in the office tomorrow after class. I have class until 3:30, but I'll be in the office from 4 to 5, and your homework is due at 5 o'clock. So if you need some extra help, that will be the time. But I'm imagining there's going to be a lot of people there, so try and get as much as you can done now. Yeah, let us know if you have any questions.